everyone. Welcome back to the Young Scientist Journal YouTube channel. Today, we are joined by a very special guest who actually won our research competition for 2021 this year. Gatik Trivedi is a 14-year-old sophomore high schooler in California. He is very passionate about biotechnology and telemedicine. As well as being a current editor here at the Young Scientist Journal, he is also an editor at the International Journal of High School Research. He serves as a student senator representing his school to solve problems related to teen mental health and substance abuse. He is a varsity competitor at the national level in congressional speaking. In his free time, he loves to play basketball, and he's even a student advocate at the YARR, a nonprofit organization for empowering the rare disease patient community to drive innovation and developments in life-saving treatments and diagnosis. Welcome, Gatik.
It's great being here.
Gatik developed a device that takes 3 measurements, which are lung capacity, oxygen levels, and temperature. The correlational algorithm in his device combines those readings to provide an indicator for his well-being. Today, we'll be asking a few questions to Gatik about his research in order to find out more. So firstly, could you explain how you undertook the whole process?
Sure. My first challenge was to find biotechnologies that I could integrate into my solution that could give quantitative outputs and results in which a comprehensive overall health solution can be found. And in order to face that obstacle, I had to research common symptoms of SARS infections and to find the parts of the bodies that it impact. So out of common symptoms, I concluded that fatigue, temperature, and lung capacity are the most evident and measurable symptoms that commonly show up in SARS-infected patients. I saw that lung capacity can be measured through FVC, which is forced vital capacity, and oxygen levels can directly correlate with fatigue. So with these measurable variables, I deducted that a thermal camera, a spirometer, and an oximeter would be the best biotechnologies to use to build an effective monitoring device. And from there, I integrated these devices using the ESP32 microprocessor. With that microprocessor, I wrote code for a correlational algorithm, which takes in these 3 values and produces a comprehensive output of your well-being. And the final step was to utilize AI and machine learning to predict trends of the data points. So overall, it was a pretty lengthy process.
Thank you, that's great. And what inspired you to undertake this research?
So my passion for accessible telemedicine started when I was working on my previous project, which is a glucose meter. But when the pandemic hit, I shifted my focus towards exploring and learning about SARS infections. So when COVID cases were rocketing up, a relative of mine got admitted into the ICU. And in a matter of days, his lung condition worsened to the point where he sadly had an untimely death. So this actually inspired me to research more. And I found that people's symptoms get really bad during self-quarantine. So I decided to build a solution that helps people monitor those symptoms to receive timely care from healthcare providers. And as the project started to come along, I focused not just on COVID, but all viruses that target the respiratory system.
That's great that you've been actually getting involved in so many projects, and I can see how this would be a great impact to many people. And what were your conclusions and impacts of your study?
So in the end, I successfully developed a novel solution that incorporates 3 biosensors onto a single platform for accurate and continuous self-monitoring of patient symptoms. I developed and executed an algorithm using C programming to correlate the data collected as an indicator of overall patient health. Also, I successfully integrated machine learning statistical analysis to evaluate predictive trends using hypothetical patient data. The most important impact of my research is that it contributes to the emerging area of telemedicine. So telemedicine enables a more streamlined process of healthcare where a diagnosis can essentially be served at home. So building a device that is capable of that is very important. In addition, the low cost and accessible aspects of my device makes it so it can be distributed to third world countries where these types of devices are much needed.
Yeah, of course, it's great that it can be used by as many people as possible and have the greatest impact.
Yeah.
And what was your favorite part of this whole process?
Yeah, so I would say that my favorite part is when I came up with the correlational algorithm for my device. I knew that I had three different devices to go off of, but I didn't really know what to make of them. So coming up with an algorithm was definitely a huge step towards the end goal. And just seeing the project being completed one step at a time was very fulfilling because I could see tangible progress. Also, I talked with a major company in healthcare, and they supported my idea and project, which was really encouraging.
Oh, that's amazing. Well done. And what are the next steps and or future plans that you have to do with this research?
The immediate next step that I'm going to take is to build a mobile app. So not only would this make reading the data much easier, but it would take accessibility to a higher level. I'm also planning to partner with the Zambia Disease Research Center to further test my device and make it scalable. Most of the testing has been done at my house, so having this opportunity to prove that it works is a really important step. So that's what's in store for the near future, and I'm really excited for that.
Oh, that must be amazing to see it go from your small home into an actual company.
Yeah, definitely. It's very fulfilling, and I'm just happy that I've had this opportunity to contribute in the scientific community, and it's been a great it's been a great year working on this project.
Yeah, and thank you for coming and submitting your research. I'm sure everyone watching at the conference and watching now has learned so much and can see the huge potential for your research. So, and
Yeah.
again, yeah, we'd like to thank you again for coming on for our YouTube channel. And I wish you the best with your project and look forward to seeing where it goes. And be sure to like and subscribe to find out for more information on anything to do with the Young Scientist Journal. And yeah, thank you.
Thank you. All right. Bye.
Bye.